Hello, today we're going to look at some trig properties. And what is the purpose of this? Well, the purpose is we are going to start to prove trig identities, which means we have to show this whole left-hand side is equal to this right-hand side. Clearly, if you can write all of this junk over here as secant of x, why wouldn't you, right? We want to simplify always our equations. So what do we need to do to get there? Well, we need 3 reciprocal properties, 2 quotient properties, and 3 Pythagorean properties. Okay, so the word reciprocal means basically flip or 1 over, right? Quotient means divide, right? And Pythagorean, hopefully you're thinking about the beautiful Pythagorean theorem, a squared plus b squared equals c squared. All right, we're going to start with the 3 reciprocal properties that we need to talk about, which are secant, cosecant, and cotangent. Just like you remembered SOHCAHTOA, you have to remember these properties as well. So secant is the same as 1 over cosine, cosecant is the same as 1 over sine, and cotangent is the same as 1 over tangent. Please make sure, I want to give you a warning, these are not inverses. Secant of theta, cosecant of theta, and cotangent of theta are still looking for side ratios. Inverse are now looking for angles, okay? So these are not inverse functions, they are reciprocals, 1 over. A lot of people get confused which one goes with secant, cosine, or sine. Just remember every function needs a co. So if you have cosine, you already have a co, so therefore you go with secant. If you sine, you need a co, so you go with cosecant. And tangent needs a co, so it goes with cotangent. All right, now we're going to look at the quotient properties. We're going to start with the idea that sine theta over cosine theta equals tangent. We're going to use SOHCAHTOA to prove this. So we know, looking at a right triangle, right, so that if this is the opposite side, this is adjacent, this is the hypotenuse, that sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. And so when I look at simplifying this, we know we never divide by a fraction. We always multiply by the reciprocal. So instead of dividing by a over h, we're going to flip it and multiply by h over a. The h's cancel each other off, and you have opposite over adjacent. And we know that is the same thing as TOA or tan theta. Okay, and so that is the proof of the first quotient property, which it says tangent is sine over cosine. And then we know that cotangent is the reciprocal, which means just flip tangent. And if you flip sine over cosine, it becomes cosine over sine. All right, the next thing we're going to do is we're going to investigate a little bit to figure out what the Pythagorean identities might mean. So I have sine squared 60 plus cosine squared 60 equals what? All right, so we can do this without our calculators. And we're going to rewrite this as sine 60 quantity squared, just different notation, but they mean the same thing. And this is cosine 60 quantity squared. And so when you're looking at this, you need to go ahead and use your exact values and figure out that sine of 60 is the same thing as a square root of 3 over 2. If you do not know your exact values, please go back, study these. They do not go away. Cosine 60 is the same thing as 1/2 squared. And now we use our exponent rules. If I have a fraction, that means I take my power to both the top and the bottom. So I have the square root of 3 squared over 2 squared plus 1 squared over 2 squared. Square root of 3 squared, so you have the square root of 3 times the square root of 3, which just gives you the square root of 9. And the square root of 9 is 3. So you have 3/4. And then you have 1/4. And 3/4 plus 1/4 is 4/4, which is 1. Okay? So we know that this sine squared 60 cosine squared 60 equals 1. Let's try another one. Sine squared 45, cosine 45. Again, I'm going to see it as sine of 45, quantity squared, plus cosine of 45, quantity squared. I'm going to remember my exact values. Sine of 45 is root 2 over 2. And cosine of 45 is also root 2 over 2. So you square the square root, so square root of 2 over 2 is going to be the square root of 4 over 4, right? And this is going to be the square root of 4 over 4. We know the square root of 4 is 2, so we have 2 fourths plus 2 fourths, which is 4 fourths. Which again is 1. So we have just showed that sine squared plus sine squared 45 plus cosine squared of 45 is also 1. All right, well maybe this only works for exact values. So let's try some out with our calculator. Let's go figure out what sine squared of 31 is. All right, so if I do sine of 31 in my calculator, let's make sure my calculator's in degree mode here. Okay, so now I'm going to do sine of 31. You have to type sine of 31 in. You can't type sine squared of 31. You could do parentheses on the outside here, but I just hit enter and then square it. And so I get 0.265. And then if I do cosine of 31, so I have cosine of 31, and I hit enter, and then I square that number, and I enter, I get 0.735. And now, if you look at this, if I do sine squared 31 plus cosine squared 31, what do I get? Hopefully you say 1. So we have showed that this is always 1. So our first Pythagorean identity is sine squared plus cosine squared equals 1. And let's just look at that as far as your unit circle goes, right? So we know our unit circle, our hypotenuse is always 1. We know that cosine generally represents x, sine generally represents y. So if you're looking at this, it makes sense that x squared plus y squared equals 1. Because we know this is a unit circle, we know the hypotenuse is always 1. This is the x, this is the y. We know from Algebra 1 that when you do, you have a right triangle and you do a squared plus b squared, it has to equal c squared. So we just showed using the unit circle that sine squared plus cosine squared equals 1. Now, from there, we are going to get our other Pythagorean identities. So the first thing we do is we take this wonderful Pythagorean identity and I divide everything by sine squared. Of course, if you do it to one thing, you have to do it to all. So not just both sides, but everything. Well, sine squared divided by sine squared is 1. Cosine divided by sine is, we just learned, cotangent squared. And 1 divided by sine, we know is cosecant, so 1 divided by sine squared is going to be cosecant squared. That is another identity. 1 plus cotangent squared equals cosecant squared. And I bet you can guess what we'd probably do to get the other one. Since we divided everything by sine, now we're going to turn around and divide everything by cosine. So if I divide this by cosine squared, divide by cosine squared, divide by cosine squared, we know that sine divided by cosine is tangent. So sine squared divided by cosine squared is tangent squared. Cosine squared divided by cosine squared is 1. And we just learned that 1 over cosine is the same thing as secant. So 1 over cosine squared is the same as secant squared. All right, there's the third Pythagorean identity. Summarize those. Make sure you have those written down or highlighted. Super important identities. Of course, if you remember this one, you can always get these two by just doing exactly what we just did, divide and by sine and cosine. And sometimes I do that. Sometimes I just take the time and do that because maybe I get them confused at which one's which. All right, so now I want to start with the identity at the top and show algebraically how it is equivalent to the statement at the bottom. So basically, I want to get, this is just extra here, cut that. I want to get basically cotangent and cosecant on the same side because that's what it has. So we just use our basic algebra properties. If I want that over here, I have to subtract it over. If I do it to one side, I got to do it to the other. These guys are not like terms, so you just write cotangent squared x minus cosecant squared. X plus 1 equals, now I have 0 on this side. And then if I want to get the 1 over to the other side, I just go ahead and subtract. And now I'm right to cotangent squared minus cosecant squared equals negative 1. All right, some other examples. We want to show which one is equivalent to cosine squared. So we start out with the idea that we know sine squared plus cosine squared equals 1, which is the same thing as saying cosine squared plus sine squared equals 1. All right? So if you want to do that, you could just go ahead and rewrite it and say cosine squared theta plus sine squared theta equals 1. And now it's easy to see, oh, if I want to solve for cosine, I just subtract sine. So I subtract sine from both sides. Sorry, kind of a little messy there. Cosine squared theta equals 1 minus sine squared theta. And the only reason I would rewrite it that way is because then I wouldn't have to move the, cosine or sine. However you feel, one goes first when we're adding. It doesn't matter which one's first. Okay, which of the following is equivalent to cotangent squared? Okay, so let's look back at our identities. 1 plus cotangent equals cosecant squared. Okay, so this is why that one showed up on that page. So if I put that identity right there, I know that if I want to just get cotangent by itself, I can just subtract 1. And so now I have cotangent is the same thing as cosecant squared minus 1. All right, hopefully that is enough to understand this material. We'll look at these problems tomorrow in class. Have a nice day.